Hi, welcome back to Moose Chemistry. This is electron configuration of phosphorus. So phosphorus is the 15th element on the periodic table. Pretty darn cool, huh? So there's 15 right there for our atomic number. And phosphorus's atomic mass number is 31. So we put 31 down there. All right. So we have 15 protons. Since phosphorus has to be electrically neutral, we will have 15 electrons. What about the number of neutrons? Well, again, we just do AMU minus protons equals our neutrons. So we go 31 minus 15, and that will give you 16 neutrons. Pretty darn easy, huh? It sure is. So let's look at our electron configuration here. But before we do that, remember that S has 2 electrons, P can hold 6 electrons, D can hold 10 electrons, and F can hold 14 electrons. We're going to use the off-Bob principle, which is the diagonal rule, which is this guy right there. And we're going to start and go down the slide like this and continue going down the slide until we run out of arrows. All right, so let's keep on going then. So our electron configuration is going to be 1s2. On the next slide, 2s2. Wow, this is so easy. 2p6 and then 3s2. 2p6 and 3s2. Well, that gives us 12 electrons. We have 2 and 2 and 6 and 2. So we're going to come back to the slide, go down to 3p. Well, we're going to put 3p3. All right, so that's it for the electron configuration. What about the orbital notation using Hund's rule? Now remember that Hund's rule says that in every suborbit, you have to put an up arrow first before you put a down arrow in that suborbit. So S only has one suborbit. Well, sorry about that. And you go up and down. Pretty cool, huh? 2s. Up and then down. Then we have 2px, 2py, 2pz. Amazing, huh? 1, 2, 3, 4, 5, and 6. And then we're going to go 3s up and down. Then we're going to go 3px, 3py, 3pz. So we have 3 of these, right? So I go 1, 2, 3. You see, that way we're doing Hund's rule. Pretty darn snarly. What about our noble gas notation? Okay, let's look at that now. All right, so let's think about the noble gas notation for a second. What is the nearest noble gas to phosphorus? Well, it's not going to be argon, because argon comes after phosphorus. So it has to be before phosphorus. So it's going to be neon. All right, so let's do our noble gas notation here. NGN, that's right, there we go. And we're going to do neon. Okay. And then we're going to look for our valence shell. Our valence shell. That's our valence shell. So we're going to write that in. 3s2, 3p3. Ah, wow, this is easier than it looks, huh? Sure is. Super duper easy. So let's look at our quantum numbers. Remember, the quantum numbers deal with Pauli's exclusionary principle, which states that no 2 elements can have the same set of quantum numbers. Well, phosphorus happens to be in the 3rd period, so the principal quantum number is going to be 3. It's in the p block, so our value is going to be 1 for our L value, our angular momentum. And since it's in the p block, we have to start counting this over. -1, 0, 1. It's the 3rd element over in the p block, right? So it would have to be a 1 right there. So put a 1 there. And let's look at our last arrow right here. That arrow is going up, right? So it's going to have to be 1/2 positive. Well, that's it for this lesson, guys. You be snarly, and we'll see you back here at Moose Chemistry.